Welcome back. A model just out of pre-training has read most of the internet, yet it can't hold a conversation. Today we cover the schooling that turns that raw predictor into a helpful assistant.
Right. Pre-training builds the brain, and that's where almost all the money goes. Post-training is the schooling that makes it polite and useful, and it's far cheaper. That's the stage we're zooming into.
So let's start with the obvious question. We just spent millions of dollars pre-training this thing. Why can't it just chat?
Because all it ever learned was one game: predict the next token. So if you ask it a question, it might just continue with more questions, because that's what the raw internet looks like. It's an autocomplete engine, not an assistant.
Okay, so how do you teach it that a question wants an answer, not more questions?
You show it the right behavior. Thousands of examples of a prompt paired with an ideal answer, and the model imitates them. It's the exact same predict the next token machinery, just on a small, curated, instruction shaped data set. And this one step, supervised fine tuning, or SFT, gets you most of the way to a usable assistant. The model stops rambling and starts actually responding.
But imitation has a ceiling, doesn't it? For a lot of questions, there isn't one perfect answer to copy.
Exactly. For most real questions, there's no single ideal answer, only this response is better than that one. So the second layer teaches the model from preferences, pairs where a human or another model judged one answer better. And this is where a whole family of methods lives.
Walk me through that family because the names are everywhere and I never know what's what.
It started with reinforcement learning from human feedback, RLHF. OpenAI's lineage here goes back to Cristiano and colleagues in 2017, then the Instruct GPT work in 2022. You train a separate reward model on human preferences, then use reinforcement learning, the PPO algorithm, to push the model toward high reward answers.
That sounds powerful, but also like a lot of moving parts.
It is. You're juggling multiple models at once, and it can be unstable. It's also hungry for human labels. So in 2022, Anthropic's constitutional AI had an AI give much of the feedback instead, judging answers against a written set of principles. That's RLAIF, reinforcement learning from AI feedback.
So one fix was making the feedback cheaper. Did anyone go after the complicated reinforcement learning part itself?
Yes, and this was the big one. In 2023, Stanford's DPO, Direct Preference Optimization, threw out the separate reward model and the whole reinforcement learning loop. It optimizes directly on the preference pairs with one simple, stable loss. It's now the default for most open source post-training.
So the field went from heavy reinforcement learning all the way down to one loss. Is that where the story ends?
No, it swung back, but smarter. In 2024, DeepSeek's GRPO brought reinforcement learning back in a lean form. It drops the reward model critic and instead compares a whole group of sampled answers against each other.
Why bring reinforcement learning back at all if DPO was simpler?
Because reinforcement learning shines when the reward is verifiable. For math or code, you can automatically check if the answer is right and let the model learn from that signal. That idea, RL from verifiable rewards, is the engine behind the recent wave of reasoning models that think in long chains before answering.
Let me try to say the whole arc back to you in one breath.
Go for it. The field started with heavy multi-model RLHF. Anthropic made the feedback cheaper with AI judges. Stanford collapsed the whole reinforcement learning apparatus into the simple DPO loss. And DeepSeek swung back to a lean, critic-free RL aimed at tasks where correctness can be checked.
Nailed it. Now, all of that schools one model, but not everyone can run a giant. Is there a shortcut to a small, well-behaved model?
There is, and it's called distillation. Instead of aligning a small model from scratch, you let a large, already excellent teacher model generate training data, or even share its internal probabilities for a smaller student. The student learns to mimic the teacher at a fraction of the size.
So a lot of those small, fast models I can run at home are really copies of bigger ones?
Exactly. Most of the small, fast open models you can run at home were distilled this way. You get much of the big model's behavior in a package small enough to serve cheaply.
So if I zoom back out, what's the one thing to take away from all of this?
That post training is the schooling that turns a raw predictor into an assistant. Imitate good answers, refine on preferences, and optionally distill into something small. Next episode, we dig into the efficiency tricks that let a small team do all of this without a supercomputer.